In this video, we're going to be learning about scale drawings and scale models. Scale drawings and scale models are used to represent objects that are too large or too small to be drawn or built in actual size. An example of this would be if you wanted to build a model of the Statue of Liberty. You couldn't actually build the Statue of Liberty at its size. You would have to scale it down. A map is also an example of a scale drawing because you can't draw distances the way they actually are in reality. You have to scale it down and make them smaller so that they fit on a map. In scale drawings and scale models, you have what is called a scale. A scale gives the ratio that compares the measurements on the drawing or model to the measurements of the real object. All this means is that all measurements on the drawing or model are proportional to the measurements of the actual object. That means they will be equal ratios to one another. Let's use this tree as an example to show what a scale drawing means. Let's say that 1 inch of this tree in the drawing is equal to 1.5 feet in real life. So we could write it like this: 1 inch of the drawing is equal to 1.5 feet in real life. So that's our ratio of the drawing, which is right here, to the tree in real life. Now the question that we could ask is, if 1 inch of the drawing is 1.5 feet in real life, how big is the tree in real life if the drawing is 10 inches? So that means in this drawing, from the bottom of the tree to the top of the tree, it is 10 inches. So what we can do is write that as a proportion. We want 10 inches of the drawing, but we don't know in real life how tall that tree is from top to bottom. But we do know that in the drawing, 1 inch of that tree is equal to 1.5 feet in real life. So since we don't know the actual height of the tree in real life, we're going to go ahead and let that be a variable, which is t. And what we can do is solve it like we would solve a proportion. So we can cross multiply and do 1 times t, which would really just be t. And then we can do 1.5 times 10, which would be 15. And actually that gives us the answer because we have nothing with t. So the height of the tree would be 15 feet. Another example of using a scale drawing is by using a scale on a map. And we're going to talk about this problem, which is on a map of New York, the distance between Albany and Poughkeepsie is 3.5 inches. If the scale on the map is 1 inch equals 20 miles, what is the actual distance between Albany and Poughkeepsie? This is very similar to the problem we just solved to the tree. So we're going to set up our first ratio that we have both values for, and that's the scale. It says right here, the scale on the map is 1 inch equals 20 miles. So they give us that first ratio. 1 inch on the drawing, or on the map, is 20 miles in real life. And that's going to be proportional to our second ratio that we are going to make. They give us in the problem that the distance between Albany and Poughkeepsie is 3.5 inches. That's the distance on the map, so we put it across from the other value for the distance on the map. So we have 3.5 inches. And the question is, we don't know the actual distance, so let's leave that as d because we don't know that. And just like we solved proportions before, we're going to start by cross multiplying. So we're going to do 1 times d, which is really just d, And then we can do 20 times 3.5, which is 70, which gives us 70 miles is our answer to the problem, which is a reasonable answer because that could be a reasonable distance between two cities. Let's try one last problem, but this time we're going to use a scale model example instead of a scale drawing. Jim is making a scale model of his family's car. The scale is that 3 inches of the model will be 8 feet in real life. If we know the actual length of the car is 16 feet, how many inches long will Jim's model be? First, let's start with the information that we know. We know the scale. It says in the sentence, the scale is 3 inches of the model will be 8 feet in real life. So let's go ahead and write down what we know. 3 inches of the model will be 8 feet in real life. Now, what we don't know is how long the model will be. So this time, we know the actual length of the car is 16 feet. Our feet, our actual length is in the denominator of this ratio, so we have to make sure we put that 16 in the right place. So the 16 feet will go on the bottom because our actual sizes have to be in line with each other and our scale sizes have to be in line with each other at the top. So this time, our variable will be at the top, and we will let that be f. We can go ahead and solve this the same way that we solved the other ones. We can solve it by cross multiplying. So we can do 3 times 16, which is 48. And then we can do 8 times f, which will be 8f. And now this is unlike the last problems because we didn't have anything with our variable. But since we know how to solve multiplication equations, we can go ahead and use what we've learned already to solve this problem. And we can do that to isolate the variable. We have to get that 8 out of there. So we do that by dividing by 8. And 8 divided by 8 is 1. So now we have f by itself. And whatever we do on this side of the equation, we have to do on the other side. So since I divided by 8 on this side, right here, I have to divide by 8 over here. So I'm going to set that up, divide by 8, and 48 divided by 8 is 6. So 6 equals f. So the length of Jim's model car will be 6 inches long.